All right, welcome back. We are Game 2014 in the fall 2021 semester, and it is week 6. Can't believe that snuck up on us. Part 1 of our broadcast and recording. And let's talk about where we sit. Again, we kind of do this every time just to give you a sense of where we're at. We're here. Last week, we talked about object pooling, and this week we're going to talk about factory pattern. Again, just as a reminder of what we did, we also did some UML. We talked about using UML as a architecture for our classes and objects, and we may have some more opportunity to practice that this week. So how do you use UML and so on. Star UML I find is very useful, but there's other programs out there as well that we can talk about another day. But they're all visual, and what they do is you create a kind of a map of what your classes and your hierarchy is going to look like before you do a stitch of code. And again, what that does for us is it gives us a plan to work from. It doesn't mean that you have to stick to the plan like anything else. It's just a plan. I liken it many times when I'm programming to doing art. I know this is kind of weird, but if you ever done any kind of painting at all or modeling, your 3D modeling as an example, or anything, I find that having a good reference is super useful, right? Because you want to look at a piece of art or you're doing modeling, and then you kind of want to look at it and see how close you are to the reference, and it gives you a chance of kind of sticking to your plan. Or if you want to go outside the reference, at least you've seen you have an example of what you want to accomplish, and you have a plan, a map, if you will. So the same thing goes with programming. When you have a UML diagram, it allows you to kind of think about your code, how it's going to connect with other code, and you might kind of think things ahead of time. It could save you some time when it comes to coding, because I think the biggest problem we have is we kind of code as we go, and coding as you go, sometimes you end up coding yourself into a corner, if you will, right? Just like if you were writing a story procedurally with no plan, and you're writing about a character, you could write yourself into a corner fairly quickly, easily, where you have to try and figure out how the character is going to get out without using time travel, which is always a cop-out in my books, right? When you see a time travel story. So at the same time, this is the same thing. You can't time travel with code, and there is no you woke up from a dream kind of ending to a story to cop out of that one as well. That's kind of the two cop outs that I've always seen. Oh, we got to time travel. There's a gateway to another dimension, or this is just a dream. Whatever. And it's the same thing when it comes to coding. When you make a plan, it gives you kind of a way so you can avoid some of the pitfalls and so on. And even when you have a plan, it doesn't mean that things are going to work exactly like you planned. You have to maybe adjust your plan or pivot, right? That's what we talked about in first year when we were talking about project management and how that works. So let's talk about this week. So that was last week. We kind of talked about the object pooling, which was a optimization pattern. We went into that a little bit. And we also, before we move on, we used a structure called a queue. So from a data structures perspective, remember our queue is first in, first out, first come, first served kind of thing. That's how we use it. And we were able to do that to optimize or reduce the ability for us to instantiate and destroy objects. That's what we did last week. So this week, we're going to be talking about the factory method pattern is what it's really called, and what that is, as well as I just wanted to remind you that assignment 1, part 2 is due next week. So at the end of the week, and as well, one thing we should also talk about for next week is the midterm tests. So we'll talk about that upcoming. Maybe we should put that down here and say something like upcoming, right? And we can put assignment 1, part 2, move these down here, which is something that is coming up, as well as, so midterm test, which is practical, which is going to be week 7. That's also what's due next week. So that's like next week as well, right? But it's the whole week. And, Vincent was asking the question as, what's going to be on the test and all that kind of stuff. What's it going to be about? How long? Typically, what we do with the midterm test is I'd like to make it so that it is maximum, or it's kind of tailored or created, measured for 3 hours, right? Okay, that's what I wanted to make it. So that would be the kind of the outside of what it's going to look like, approximately 3 hours, right, in length. It's going to basically allow you to go over some of the same things that you've already seen. So it's nothing new, in terms of like what we've shown you, maybe a modification of what we've seen, but, and just in terms of everything that's happening, I think you're going to see that. Let me just move this. Let me move the lab up since this is this week, right? So I think that's what the midterm test is about. And I'm reminding you, so what I'll be doing is next week, again, early on in the week, Monday timeframe, I'll open up the test for you and you'll have it for the entire week for you to do that. There won't be a limit onto how long you can work on it. I'm not going to time you. But again, you should use the 3 hour mark as in a kind of your own measurement on how you're doing, right? So if you take longer than 3 hours, there's two reasons why you might take longer than 3 hours. One of them is you're not good at Unity and you need to practice more, right? That's all it is, right? You need to spend more time working this out. The other option is that you want to add more stuff. Like you're super happy about using Unity and playing around and you want to add more content, that's required, then it's required, right? And that's fine too. But I would caution you all, don't go too crazy about this. Remember, just stick to your checklist. So I give you usually a document, and you go through the checklist, the entire checklist, and kind of go through one item at a time, and make sure that you hit all the highlights, the things that I've asked you for, and that's it. Okay, so don't try and be a hero for next week. You have a lot of stuff, other things on the go, other than just me. So just get it done and do what I've asked you to do, and you're going to be fine. All right, so that's kind of what's upcoming. All right, any questions around Lab 3, which we kind of started with last week? Object pooling, we started doing design patterns, and we'll be continuing with design patterns this week and ongoing through the semester. So that's what we're doing. And of course, the stuff we're going to be talking about this week is all around this stuff. The dependency inversion principle, what that is, what's the factory design pattern, how can that help us? It's a structural pattern. And as well as how do I do simple animations for mobile? You guys should know how to do simple animations already. We'll talk about how to do that, in our case, for the stuff that we're doing. Okay. Actually, the question is, here's a question. Do you guys know how to do simple animations already in Unity? And some of you, if you do, check mark. If you don't, X. If you don't know how to do that, we'll go through a method that I can show you. Good, that's good. So this will be a review for some of you, which will make it nice and easy for you guys. And for some of you, it's new, and that's okay, right? If you don't know how to do animation, thank you for the feedback. If you don't know how to do animation properly or how to trigger it, I'll show you my way of doing it, a simple way. There's many other ways to do the same thing. All right, let's get to it then, if there's no other questions. So this is interesting. We're into creational design patterns, and there'll be a couple of them that we're going to be talking about today. And what they allow us to do is they provide us, like it says here, with object creation mechanisms. And that's the main piece here, object creation mechanisms. And so we have two of them we're going to be talking about today, the factory method, as well as the abstract factory and what that is. And why would we need these? What problems do they solve? Let's talk about that. So first, before we even talk about factory method, let's get into solid. So sometimes what we talk about is different design principles. One of them that I like to use is called dry, which is do not repeat yourself, the dry principle. There's also solid, which has different acronyms that we're going to learn. And one of them, the D in solid, is called the dependency inversion principle. And again, this is something that was defined back in the 90s. And what is this thing? It has two parts. High-level modules should not depend on low-level modules. Okay, cool. Both should depend on abstractions. And this is an important piece, right? Abstractions should not depend on details. Okay, and details should depend on abstractions. So when we think about what these things mean, obviously the author of the dependency inversion principle try to keep it as abstract and ambiguous as possible, so we can apply these thoughts, these principles, to many situations. And when I think about these, before moving on, I always think about interfaces, right? Or components. I want to think about some components that I want to snap on to a class, as an example. And then when I start thinking about components like this, I start thinking about this part, number 2, which is abstractions should not depend on details. I create an interface, and the interface itself describes a specialization, perhaps one method or two methods. And so we won't define the details here. And this helps us with polymorphism in some ways, right? So example is I define a method called drawable, iDrawable, right? As an example. And maybe that method has a class iDrawable, which is an interface, has a draw method. And the draw method isn't defined inside of the interface. It's designed inside of when we use it, right? Inside the class itself. So details should depend on the abstractions, which means it's going to depend on extending an interface that we define or we declare outside of the class. And of course, once we start doing that, then the class itself has two things. It has something that it's inheriting from, in this case, when we use Unity, mono behavior. And the other thing is it also can extend or we can say that it implements the interface, whatever that interface is. So those words, again, this is a review of object-oriented programming principles. Let's continue with that idea. So the factory method then is a creational design pattern. It's also known as the virtual constructor, which is very interesting. And it provides an interface for creating objects in a superclass, but allows subclasses to alter the type of objects that will be created. Okay, so that's kind of the factory itself. And here's the problem. So imagine that you've created a transportation simulation, and the first version of your app can only simulate transportation by trucks, right? So the bulk of your code lives inside the truck class, okay? So the truck class. And if you think about what that is, so that means I can only make trucks. And by the way, one thing that we can do is once we create if I instantiate stuff, as an example, then I only get the thing that I'm instantiating, right? However, we notice a lot of times when we instantiate things that the thing that we're instantiating is very similar to other things. Let's say, for example, I'm making an enemy, and the enemy has some kind of AI brain, and I'm making different kinds of enemy, but they all have an AI brain. They're all going to follow a behavior tree or something like that. Then there's similarities, right? And we think about, well, if all I'm switching out is the way the animations work on the AI, and the type of AI, I can kind of turn on switches or kind of create, what I want based on my configuration. So instead of me kind of having the user use my class and put in the proper order, put in all the configuration details when they instantiate an object, we don't do that there. We do it in the factory. We kind of call the factory to help us make different objects. Well, let's go back to this. So after a while, it says our app becomes really popular, and each day we receive dozens of requests from the sea transportation companies to incorporate sea logistics into the app, because they know we can do trucks. Wouldn't it be nice to use sea logistics as well, right? So it's not so simple, because we've already made a logistics app just for trucks, and now modifying it so that we can do sea logistics as well. Well, that means a whole rewrite, doesn't it? So, what can we do? We can make a truck class, but adding ships would make a lot of changes to the code base. And later on, what if I wanted to decide to add other kinds of transportation simulations? For example, some kind of planes or spaceships or whatever. It could be really bad, and the reformulation or reworking, refactoring of my app could end up doing a lot of things, like breaking my first simulation, because I've already created a simulation based on a bunch of classes that are concrete classes that I've created. And in this scenario, I'd have to do a lot of rewriting. It could actually mean a whole new app, kind of very different than what I had, earlier on. So what's one of the solutions? We can use the factory method pattern, which what we can do is we can replace direct object construction, example using the new operator in C#, with calls to a special factory method itself. And don't worry, we still create the object with the new operator, or in our case in Unity, we use instantiate. We can still use instantiate, but it's being called from within the factory, as opposed to, kind of loose, throughout our code. And one thing that happens is objects returned by a factory method are often referred to as products. Okay, so we get a product from the factory, and the product that we're going to get is based on some switches in the parameters that we used when we call the factory itself. And it can do a lot of really cool things. Okay, so let's talk about how this works. Okay, so what does this look like? This is why I got you guys to start looking at UML. Here is some UML. And whenever I look at UML or pseudocode, this is kind of like pseudocode for me too, right? Pseudocode and UML sometimes is kind of, we kind of swap one thing out for the other. They're not synonymous, but we can kind of, use both of those two tools to create our code. So here's a logistics class. You can see that in this case, when we look at the diagram, without anything else, you guys should know two things when you look at this diagram. One, logistics is the superclass for road logistics and sea logistics. Okay, you can see this is the superclass. Okay, and we can see that the road logistics and sea logistics classes are specializations of the logistics class itself. Okay, there is a method. Both of them there's two public methods: plan delivery and create transport. Okay, notice that the create transport operation or method is being overwritten here. And notice also we're inside the logistics abstract superclass. We can tell that it's abstract from a couple of reasons when I look at this diagram. And again, I'm showing you this, guys. We're talking about this because I want you guys to, to recognize some stuff. Notice this is italicized. Logistics is italicized. And so too is this method, create transport. Okay. So the create transport method and the logistics class itself are both considered abstract. Okay, so they're both abstract. And what this means is that you do not instantiate an object of type logistics directly, right? What you do instead is you use your subclasses or child classes, road logistics and sea logistics, to instantiate objects. Okay, so again, subclasses can alter the class objects being returned by the factory method. So the factory method returns something, and then depending on the object that you're going to get, whether it's road logistics or sea logistics, road logistics would modify. This is the perfect view of polymorphism. I would return when I use the create transport method, here it returns a truck, and the create transport method of the sea logistics class returns a ship. Okay, so different kinds of things, but they're both some kind of method of transport. That's what we're returning. So the abstract superclass kind of binds together those two things that are common, right, as an example. Okay, so that's something to note. Notice that when I return an object, I return an object of type transport. When I use create transport returns an object of type transport, whatever transport is. And it's usually something that's contained, or maybe it's another class itself, the transport class. That is, and composition is different than inheritance in that we can use another class to compose or create, if you will, a transport object. And the transport object is going to be the same, right? So whether it's a truck or a ship, they're both considered transport objects. So interesting. The other thing we can think about, instead of using just composition here, is maybe the logistics class itself, just by looking at this, inherits from transport. Okay, it inherits from transport. But I doubt that that would be the way that we would do that. Okay. All right, so that is the first piece, just understanding the way the solution would look. Any questions around UML, and did they see this thing any differently than the way I've kind of thought about it? So Vineet says italics. This is where the must override comes in and not may. Yes, I agree. Create transport must be overridden and implemented by the subclass, but plan delivery might be optional. Agree. All those things are good, right? Because both plan delivery, something else to note is because plan delivery and create transport are both public, they're both accessible from the subclasses, road logistics and sea logistics, right? If plan delivery had a minus in front, it'd be private and only available inside the logistics class itself. Okay, so those are the things that we want to specify. So very good. Thank you, Vineet. All right, so let's go to the next slide. So again, at first glance, when we look at this thing, it looks like it's pointless. Why would we just do this? We move the constructor call from one part of the program to somewhere else, right? However, consider this. Now we can override the factory method in the subclass and change the class of products being created by that method, whatever that is, right? And there is a slight limitation though, and one of them is that subclasses may return different types of products. Okay, and only of these products have a common base class or interface. Remember, we just talked about interface with the, kind of the first thing we talked about above all this, which was here in the dependency inversion principle, right? And interfaces. Okay, so going back to you guys, interfaces. Do we remember what interfaces are before we move on? Because this is something we need to kind of tackle. What is an interface, kind of compared to a class? Does anyone remember? This is like C# 101, but it's not C++ 101. What's an interface compared to a class? Does anyone remember? Does anyone know? So Maxim says a pure virtual class. Yes, but pure virtual is in many ways also called an abstract class. So in C# we actually have another type of object called an interface, which is not necessarily a class. We'll talk about that today in our Unity stuff. Vineet says interfaces cannot be instantiated, classes can be. Yes, it's true. Vincent says class with a function that can be shared to whoever's inheriting from it. Yeah, so instead of inheritance, we think about them as implementations. In other programming languages, interfaces are also called protocols, right? We can only implement them. Good. Abdul Hakim. And the reason for that is because when we think about interfaces, and some people are like, well, I don't understand why interfaces why do we even use them? Yeah, exactly, Maxim and Swift. So why do we even use interfaces? Because they don't do anything. They basically just declare or forward declare methods. That's all they do, really, right? Well, there's some really great things we can do with interfaces. Like one thing is we can identify a product of a factory, and we can say there that, let's say this, this class implements, as an example, this particular interface. And let's say that interface just has one method that we want to implement. We want to define that method. And if my class outputs an object of whatever my class with the method and the superclass that it includes, we can identify it. We can say that it's of type drawable, or it's of type observable, or it's of type commandable, or it's of type whatever. And so you can actually you can use detection to detect what kind of object you're getting back. That's one thing, one way you can use it. The other way is we can also think about interfaces just like using multiple inheritance in some way. It's kind of like C#'s way of using multiple inheritance, where we're saying, hey, you know what? I can't do multiple inheritance in C#. I can't do multiple inheritance in Java, those two languages they just don't agree with that principle. They avoid multiple inheritance, whereas in C++ you can, although it's dangerous, right? It can be. But we're going to use interfaces and protocols instead. And the reason for this is because we can kind of say that, we want to plug in a feature, but we want to kind of be able to identify when that feature is plugged in, right? We want to be able to identify a class and say, hey, that class is of type iDrawable or iUpdatable or I whatever, and you define that. And usually you put the I in front of the interface to indicate that it is an interface we're creating. We'll talk about this in a bit, the implementation piece. Okay, so again, one thing is the base class, which is the superclass or the base abstract class, should have its return type declared as this interface, whatever that is, okay? Let's go further. So again, you have an interface called transport, right? And the interface itself doesn't have any kind of implementation details for the deliver method. The deliver method is just something that is empty. It's declared, but not defined. And we don't define it here in the interface, right? Notice that there's a different kind of relationship that truck and ship have with transport compared to what we had earlier, the solid line, right, that we have with logistics. So road logistics and C logistics inherit from logistics superclass, the abstract superclass, right? Whereas in this scenario, truck and ship as objects or as classes, right? They don't inherit, but rather they have a different kind of association, right? And this association here is they implement the transport interface. So then truck delivers, right? When we use the deliver method, that must be overridden. Again, anytime you implement an interface, you must override the method that is declared in the interface itself, okay? As an example, and we still deliver, but we deliver different ways, different methods. We deliver by land or we deliver by sea, okay? So this idea is what we're talking about, interfaces. So again, both truck and ship, they implement the transport interface, which declares a method called deliver. Each class implements this method differently. Trucks deliver cargo by land, ships deliver cargo by sea, and the factory method in the road logistics class returns truck objects, whereas the factory method in the C logistics class returns ship objects, right? And this code that uses the factory method, often called the client code, it doesn't see a difference between the actual products returned by the various subclasses because they're all transport types. All right, so that's the beautiful thing about it. So now it can look more like this, a different kind of diagram, where the logistics app can return different kinds. All we get is a transport object returned, right? We don't care what type of transport object it is. It doesn't matter if it's a ship or a truck or a plane or a spaceship. We get transport objects, and which is the really cool thing about it, okay? And we can also think about things like this, okay? So this is something interesting as well. Here's the steps, and these are very interesting. I want you to think of it like this. When you create a classic factory, okay, this is a classic factory. We may not go into so much detail with our Unity implementation, and there's reasons that I'll talk about in Unity in a bit. But here's something. I first create the interface for the product that I'm going to return, okay? And then once we create the interface, we create two types of products, a concrete product A and a concrete product B, okay? These are both product types. Notice that product would be the interface, okay? So I make two types of products, a product A or a product B, but they're still products, okay? I want you to think of this now for a second. And then when I make my creator class would be an abstract superclass. That'll be my factory, the factory itself. And this is kind of like an abstract class that we're going to use as a pattern for both two types of products that I'm going to create. I can create product A or product B, right? But what I'm going to be doing is instead of doing it here with the creator, I'm going to have two separate concrete classes. Remember, the difference between abstract and concrete means abstract, you can't make an instance of this type of class, right? You can only use this as a blueprint for other classes. And these concrete classes are where we actually do the instantiation. So again, we return a new concrete product A inside create product. Okay, so that's the way we do it. And what we do typically, and I'll let you know this as well, is concrete creator A and concrete creator B, whatever those two classes are called, a lot of times they're singletons. So we'll talk about that a little bit as well, how to make a singleton. All right, so that is concrete A, concrete B, and your interface. This is typically how we do it. Now, why this separation? Why product A and product B? Well, I want you to think about what these things are, right? So imagine if I have one prefab that I make here and another kind of prefab that I use here, right? As an example, the interface itself that has the do stuff method, in this case, again, this is just a blueprint for other things. Then when we think about the do stuff method, see this little line here? This little line, right? It returns a product, which means there's a dependency, or we're using something called, we're implementing the interface here at this level here, at the creator level. And that means that both concrete creator A and concrete creator B are both product types, right? They both return products, okay? So, again, the other way to do it would be we create the interface and then we use the interface itself as a composition. We compose the create product method that returns the product, the concrete product that we want here in concrete A and concrete B. Again, these are like the terminology I'm using may not be familiar to you. Like you might look at it and go, what the heck is Tom talking about? Concrete versus abstract. You guys learned C++, and now I'm talking about C#. And it's a totally different way of thinking about it when you program in C# than you do in C++. Because in C++, everything is an interface. If you think about it, a .h, any kind of header file, is really the interface, right, for what you're creating in the CPP. Here, we don't have that because the CPP and the .h on the C# side is kind of one big class, typically. You can make it so it's broken out if you really want to. You can break out declarations from definitions, right? But typically in C# you do not. Okay, let's move on. So that is, kind of a high-level way of structuring your class. This is one way, the classic way of structuring your factory, okay? So again, the structure is the product declares the interface, which is common to all objects that can be produced by the creator and its subclasses. Concrete products are different implementations of the product interface, and this should actually be the capital P product, right? So concrete products, okay, this is what it should say. The creator class, this is the factory itself, declares the factory method that returns a new product object, whatever that product objects are. So product objects is what we're saying here. And it's important that the return type of this method matches the product interface. So whatever the product interface is. And it should really, again, be capital P product, not a lowercase p product. Here. Concrete creators override the base factory method so it returns a different type of product. And it says, note that the factory method doesn't have to create new instances all the time. It can also return existing objects from a cache, an object pool, or another source. What other source would it be? Prefabs. Okay, so we can also return prefabs as well. It doesn't have to also, make new instances all the time. And I think this is great. Think about this, that if my factory method can link with my object pool, what am I doing? I'm saying, hey, object pool, I need another one. I need another one. I need a bullet, whatever that bullet's going to be, right? But I need a special type of bullet, okay? The other thing that you can think about is, what if I have different kinds of bullets? I might have a bullet that is the enemy bullet like we did last week. But what if I have another type of bullet? I have the player's bullet. And depending on the factory method I'm using, instead of directly calling the bullet manager itself. I don't call the bullet manager. I get the factory to call the bullet manager. Okay. So different ways of doing the same things. So here's the applicability. So we use the factory method when we don't know beforehand the exact types and dependencies of the objects your code should work with. We don't know. But we know there's different kinds. We know that there's going to be a ship or a truck or a plane or a spaceship. We're going to do all these different kinds, but I don't know which one I need. I'm going to need something, and depending on what I want, I'm going to call it into being. I'm going to instantiate or breathe life into my object, right? So think of it this way as well. For how does this apply to games? I have an enemy type, I have a monster type, I have some kind of spawner, and I want to spawn different kinds of monsters with different kinds of AI, right? So low-level AI, which is very simple, maybe some kind of line of sight and that kind of stuff, and a higher level AI that has behavior trees, that uses a form of behavior, or reinforcement learning as an example, where the AI can actually learn from its mistakes and actually get better and faster and smarter, right? So I can plug in different pieces in my AI, but instead of using a direct instantiation, I go through the factory, and the factory will take my parameters, spin them into a new object, which I can use later on. And there won't be potentially only one instance of an object that I can create. Maybe I can create different kinds of objects, but they're all related because each object might be a type of enemy. And we'll talk about that in a bit, how to do it. All right, let's continue. So that is applicability. Other things we can think about is if I want to make a factory method when you want to save system resources by reusing existing objects instead of rebuilding them each time. So in other words, if I want to tap this or connect this to object pooling, all right, this is a great time to use this, right? And instead of using things like large resource-intensive objects, such as things like database connections, network connections, file systems, all that kind of stuff, this is another good time to use the factory method pattern, right? Some advantages, you can avoid something called tight coupling, all right, which is really great. That means I can plug in, and I can add new, opportunities, if you will, to create new types of objects through the same factory. So I just have to modify one piece of code, and then all of my subclasses can create different kinds of objects, right? One thing is we also have to think about is one thing around design patterns is the solid. Remember the solid, the term solid? Well, the first S in the solid is single responsibility principle, which means you can only do one thing. Each class or something that we're creating, a factory or a class, can only do really one thing. Methods should only do one thing. Classes should only do one thing. And so factory method supports the single responsibility principle because we can move the product creation code into another place of the program, making the code easier to support as it only does one thing. Here's the O in solid, the open close principle. And what this means is that you can introduce new types of products into the program without breaking existing client code. All right, so that's important to do as well. So I can still use the same client code later on, and so now what happens is my object becomes, or my code becomes more extensible. Whereas if I wrote a specific truck instantiation class, concrete class for trucks, then all I can do is make trucks, and then I'd have to rework my code to allow them to make ships as well. And I don't want to make like a truck class, a ship class, 15 classes necessarily. Not like that. I want to be able to create the different objects I need, but through one interface, one entry point, if you will, which would be the factory. Okay. How about some disadvantages? My code may become more complicated, which is, some of you might be thinking that right away. When you looked at this code, you might like, wait, that's like more code I have to make, right? And I have to create new structures, and new structures means more memory footprint. Yeah, might, but it's also more extensible. And here's the best case scenario is when you're introducing the pattern into an existing hierarchy of creator classes. If it already exists, we're all good to go. The worst case scenario is I have to rework a lot of the stuff. If I already don't have this, or I didn't plan for a factory, then reworking the code to include a factory can take some redoing, like, almost like a redo altogether. All right, so that's kind of a disadvantage. There's going to be some more higher level complexity and more abstractions in our code than we would normally have. All right, so questions around factory method pattern. Anybody? Does anyone not understand why they would use such a thing? And in Unity, some of the questions I always get is, well, why do I need it? Because I already have a prototype like, a prefab. Why do I need a factory for that? In many ways, the answer, I'm going to answer my own question because you guys aren't asking. But in many ways, what it comes down to is, if you're passing your code off to somebody else, right? If I pass my code off to somebody else and I want them to instantiate my object perfectly, they may not. They may not know how to instantiate objects the way I want them to, right? But what a factory does is it sometimes acts as a middleman, to perfect instantiation. The factory itself might take 2 options, but instantiate 10, right? 10 different. They might use 10 parameters inside the factory itself, but all you have to kind of say is, I want a first level enemy. What does a first level enemy mean for you? It might mean someone that's low level, and you can say, where is it? I want a first level enemy that operates in the sand. Okay, cool. So imagine that, right? And if I say that to my factory might go back and say, okay, low level enemy means I need to plug in this kind of AI brain. In the sand, that means I need a crawler instead of or a walker instead of some kind of wheeled object, as an example, right? So now I'm instantiating a different kind of object. There might be like 15 different kinds of objects I can instantiate, but instead of putting 15 different options or parameters, I can use the factory to do that for me. It's the middleman. It's kind of exactly like that, Sam. Yeah. So I assemble the product, right? And you might have components, this idea, but the factory itself is I can make different kinds of products, I have a bunch of different products to make that are related in some way, right? And I want to use the factory as my delegate, if you will, to create the product properly, and to use basically to do all the configuration for me. Instead of me doing all the low level configuration, and instantiate the object through a constructor, the factory is going to use the constructor for me, as opposed to me doing the configuration up front. And what that does is it makes it, again, for junior programmers, if they use a factory, it's much easier for them to use the create, enemy factory, as opposed to them making an enemy by using the enemy class. Okay. All right, let's move on. So that is the first part. Abstract factory. Okay, so we have the factory, but then why is this another level of abstraction? Why do we need this? And by the way, I want to talk about this as, remember that there's 23 design patterns, but over the years, people have taken them and extended them and made them more useful. And the abstract factory is an extension of that, just that, all right? So again, another creational design pattern. And what it does, it lets you produce families of related objects without specifying their concrete class. Okay? So there might be, the concrete class might be the specific type of enemy. For example, something like blue enemy with red wings, as an example. That might be the concrete class, right? The factory takes care of that. The factory takes care of that inside of it. So here's an example. I have the abstract factory, and now in this image here, we have a spheric factory and a pyramidal factory, and they both make some kind of furniture. All right, this is the idea here. They make furniture, but we don't know what type of furniture they're going to make. It could be spherical, could be pyramidal, it could be rectangular. We don't know, right? But we're going to use the abstract factory to make the type of a furniture line. So here's the problem. Imagine that you're creating a furniture shop simulator. Your code consists of classes that represent a family of related products. For example, let's say chair, sofa, and coffee table. Those are the same problem, same product. But several variants of this family, for example, products like chair plus sofa plus coffee table, are available in these variants: modern, Victorian, and Art Deco. All right, so here's the example. So Art Deco, you can see that there is a chair, a sofa, and a coffee table. They're all kind of the same style. Victorian, right, and modern. Okay, so kind of different kinds, different product family lines or variants, if you will. Again, what we talked about is there's a couple ways to implement this. One way is to just send off the types. I might say something like this. I might say, I want the style would be Art Deco. The object is a chair, okay? And there might be another third thing that I want. Where do I want it, as an example, right? So now, instead of me making a chair, right, or I want to make a chair factory, I'm not making a chair factory anymore. The factory that I can use can make anything I want, whether it's Art Deco or Victorian or modern, right? So I can have many more products, but they're all related again. And there's different relationships. These are all chairs. You can say that this is a chair. However, these are all of style or implement the style called Art Deco, right? So they're Art Deco type chips. So there's two potential interfaces we can use here instead of one. Okay, kind of interesting way of doing it. All right, so again, here's the problem. I need a way to create individual furniture objects so that they can match up other objects of the same family, and my virtual customers get quite mad when they receive non-matching furniture. For example, something that looks like this, where I have some kind of Art Deco where, you have Victorian chairs along with it. And then you can see the customer saying, something just doesn't look right, Or imagine I'm making a VR game and I want to instantiate, procedurally generate certain rooms, and then the rooms don't quite match in terms of the stuff that I have in them, okay? So, and I also don't want to change the existing code. Here's another problem. I want to solve this problem when adding new products or families of products to my program, because again, if I change the codes, I can break stuff downstream. Remember, because one of the problems with inheritance, people always complain about inheritance being like a cancer. You modify one thing upstream, and then anything downstream, it's like a domino effect. It affects all the other classes downstream, and it can be a problem, right? So we want to avoid these problems by, putting some of these structures in place ahead of time. Okay. The other thing here, it says furniture vendors update their catalogs very often in this scenario, and you wouldn't want to change the core code each time that happens. So I had, instead of adding, these three types, Art Deco, Victorian, and modern, maybe there's something else. Maybe it's going to be 10 more things in the future. What if I want to make a DLC, for my game that has other styles of objects or different kinds of textures that I want for guns or for objects? I want to make my code extensible, so that way when I add different kinds of objects, or I add a DLC in the future, I can use the same patterns that I already have, and I can use the same constructs, things that I've already designed, but just modify the guts of them without the user knowing, that gives other capabilities. So that I don't break anything that I already have, but I just add capability to the same classes and objects that I know. All right, so that's how it works. So here's a solution. We use the first thing the abstract factory pattern suggests is the explicit declaration of interfaces for each distinct product. Okay, so interfaces is important. So example, chair, sofa, and coffee table. Then you make all variants of the project follow these interfaces. For example, all chair variants can implement the chair interface. All coffee table variants implement the coffee table interface, and so on. Okay, that's the first part. And it might look like something like this. So here's chair. A chair itself has two methods, has legs and sit on. Okay, has legs. Obviously, whenever we see has anything, it means that this is a Boolean. Does it have legs? Yes. True. And if it doesn't have legs, false. Right? So chair, and then sit on would be the method that we can use. And we must override the method in the variation. So for example, Victorian chair or modern chair, we must override the sit on method as an example. But has legs, which is interesting, right? There's different kinds of legs. Here in Victorian chair, you can see that this one has legs, whereas this one does not, right? It doesn't have a leg. It has some kind of weird base, right? Different kind of chairs. Some chairs have legs, some chairs don't, right? Okay, so let's continue. So the next move is to declare the abstract factory. So first we declare the interfaces that we need for each type of object we want to create. And then an interface with a list of creation methods, right, for all products that are part of the product family. For example, create chair. We don't know what kind of chair it's going to make. We don't know if it's going to be Victorian or modern or Art Deco or anything like that, but we know we're going to make a chair out of it. We're going to get a chair, all right? So we're going to have create chair, create sofa, and create coffee table, and these things must return abstract product types represented by the interfaces we extended previously, chair, sofa, and coffee table, and so on. We don't know what they're going to make yet, okay? So what about product variants? Well, now we make a separate factory class based on the abstract factory interface. So in other words, we make subclasses of the abstract factory, right? And those things are modern factory, and modern factory basically creates modern chair, modern sofa, modern coffee table, as opposed to the other one. So here's how it looks: furniture factory. And then you have your Victorian furniture factory or your modern furniture factory. Again, it spits out different kinds of products. By the way, there's also other ways to do this, where you have one factory method, right? As an example, one furniture factory itself, and the create chair takes parameters, right? And the create chair parameters takes the parameters. There's different kinds of interfaces. It's a chair, coffee table, and sofa. But we also can implement another interface for the type that it returns, which is Victorian or modern. Okay, we'll talk about that maybe later on. So the client code has to work with both factories and products via their respective abstract interfaces. And what this allows us to do is change the type of factory that we pass to the client code, right? As well as the variant that's produced. All right, so here's an example. Give me a chair. And then there's a special type of chair, this little thing here, and I don't care. You factories all look the same to me. This is a great thing because as far as, the client knows, factory is a factory is a factory. As far as what is outputted, it really depends on what the client is looking for. If the client's looking for a Victorian chair, then we're going to use the create chair method, which is going to return a type of chair, but we don't know what type. It really depends on the factory that's calling it. So let's go further from a structure perspective. I like to look at these. Again, I have product A and product B. We define these first as an example, right? And then you can see that there's an abstract factory, and these two things kind of point to the abstract factory interface. The abstract factory itself is an interface. And the concrete factory would be the specific type that it's going to make, right? So example, I made a furniture factory. So Concrete Factory 2 and Concrete Factory 1 are both implement the Furniture Factory interface, which have two creational methods that create chair and create coffee table. There's another one, maybe a create product C, which would be the, sofa or whatever, right? So these are the three that they make as an example. And so these two have the same things. They're both of type furniture factory, but Concrete Factory 1 and Concrete Factory 2, this would be Victorian, and this one would be modern, let's say, right? And what they do is they spit out different kinds of product types, right, depending on the structure itself. And this is a good, solid representation of how it would work if you have a very complex structure, all right? Notice also there's something called client. And the client, what it does is says, hey, notice that the factory itself is a private instance member, right? And so it keeps a reference to the abstract factory that it's using. And in our client code, we say, we want to pass in of the factory that I need, and we have some operation that creates the product. For example, here, product A, I can say factory.create product A, right? And create product A, well, that means it would make either this one or this one, right? That's how the client interface would look. Okay, again, whenever you look at these kind of things, take a look at the connections that we have, right? Take a look at the connections. These dotted connections mean interface, right, or association. These solid lines right? They're generalizations, or they mean inheritance, right? So product A and product B, concrete product A and concrete product A, A2, they both inherit from product A. This might just be a Victorian chair compared to a modern chair, but they're both chairs. Okay? But what's produced depends on which factory you're calling. Okay? And that's what I've kind of defined here. I'm going to skip through these. I'm not going to read through each of these. So when do I use it? We use the abstract factory when your code needs to work with a bunch of families of related products, right? But I don't want it to depend on the concrete class of those products because, again, future extensibility, I want to abstract as much far away. I want to continue to decouple my code. So instead of having tight coupling where there's dependencies, I want to remove dependencies as much as possible. Vincent says, sorry, dotted means association and solid means, generalization or inheritance. Okay, typically. And there's the other one too, Vincent, this one up here, which is kind of like a calling class. And notice that we're not inheriting from abstract factory, but rather we're using it as composite. We're composing the client is using composition to compose the type of object that I need, depending on the factory that I'm going to create, what the client requires. So, okay, Abdul Hakim. So you're saying what's the relationship between concrete factory 1 and the concrete product? Okay, well let's take a look at this. If I look at concrete factory 1, remember it produces type concrete product A, the method, or create product A method creates a type that I already have. I make these types first. They're solid, right? So for example, enemy bullet. And over here, there's player bullet. So imagine if I had all enemy bullets being here, right? And all player bullets being here. This could be a way we could use this, right? So if concrete factory 1 creates enemy bullet types, right? So I can make different kinds of bullets, a bomb, they're related, right? I can make 3 types of bullets or attacks. I can make some kind of, a piercing bullet, an area attack bullet, and some other type of bullet that, I don't know, some kind of a seeking bullet, let's just say. All right, those are the 3 types. And not only can I have these 3 types of the actual bullet themselves, so piercing bullet, area bullet, and seeking bullet, that would be concrete product A, product B, product C, right? Right? Product A, product B, product C. Those are the superclasses because they do the same thing. They're related, right? Whether it's an enemy bullet or whether it's a player bullet, my piercing bullet is still going to be something that I can have as an enemy, the enemy piercing bullet or the player piercing bullet. These are specificities, right? They have different colors, different textures. They have different damage that they do. As an example, but they're all piercing bullets. That's the product type, right? So create product A for the enemy. If this is the enemy class, they would make a enemy piercing bullet, right? That's what the concrete factory would make. And that's the relationship between these things. These are all concrete, and the factory would create an object of type concrete product A or concrete product B, tuned to the specific type of bullet that we need for that particular factory. For example, enemy bullets, not player bullets. Okay. I know it's kind of way out there. And until you start doing it, you're like, when you look at this thing, you're like, wait, what? How? Why? Why all this extra code? Because of extensibility. Because we want to be able to think about it and ahead of time and say, I'm going to come up with these situations again where I'm going to have another type of bullet. For example, I have, enemy bullet, I have player bullet, maybe I have NPC bullet. Just saying, right? And you can create as many of these types of bullet types as you want, but the flavor, the way they look, is these ones. This is how they would look. Texture, damage, whatever, right? But these are the types. Piercing bullet, some kind of area attack bullet, some kind of seeking bullet, some kind of, whatever. And you can go to this scenario. You can use this analogy for anything you want, right? some kind of ranged enemies, some kind of close combat enemies, some kind of enemy with close ranged enemy that has close combat capabilities, some kind of burrowing enemies, some kind of flying enemies, some kind of, you can do all kinds of stuff like that, right? So, you can actually have that as modes of transportation. So how do they get there? They do close combat or fly, or ranged, but you could have two concrete factories. One factory would be for all flying enemies. The other one could be for all crawling enemies. Another one could be for all burrowing enemies. But they're all still close combat or ranged. Maybe one of them spits, a burrowing enemy that spits some kind of poison. A flying enemy that spits fire. Another, an enemy on the ground, that uses some kind of bone attack where they use, throw bone shards or whatever. But they all are ranged enemies. Okay. Sorry, I know I've gone to details here, but the idea is, how do you rank those? How do you have multiple enemy types? How do you have multiple things of the same type? And how do I reduce code? I'm going to write the code, and I want to reduce, kind of things that are repeating. I don't want to have repeating code. I want to reduce that. I want to kind of repeat less in my code, and to do that, I can use this pattern. So we talked about the structure, and that's nice. But what about applicability? When do I use the abstract factory? When my code needs to work with various families. We want to talk about, again, extensibility. And the abstract factor provides with an interface for creating objects from each class of the product family, as long as your code creates objects via this interface. If we keep using the same interface, we're all good. And that can be also a disadvantage. We'll talk about it in a second. So here's advantages. You can be sure that the products you're getting from a factory are compatible with each other. They're all chairs, as an example, or they're all modern. I can kind of check to see which type they are, right? Again, I avoid type coupling like I talked about before. So I don't have to only create one type of object. I can make a family of objects, right? Single responsibility principle. I only make one class only does one thing. They only create one type of object, all right? And then, again, I can introduce new variants, no problem. On the disadvantage side, the code, again, continues to become more complicated than it should be. Sometimes what happens is, if you come into an application or a game, you and I are making a game, and that's fine if you and I are making the classes and objects, but what if I bring somebody new in? Now they're going to have a learning curve to figure out how my code stitches together, because I'm using abstract classes and objects as opposed to directly instantiating stuff, right? So they're going to ask the questions, well, why are we doing this? Well, because I can make different kinds. And also for junior programmers, it might be a disadvantage because they don't know why it's happening. Why are we using this middle layer as opposed to instantiating stuff directly? Well, because we have a very complex game that uses different things in it. Yes, concrete product is a data type for sure. Let's continue. So here's some uses in games, and here's the enemy spotter. So create an enemy interface that has an attack action method. Create concrete classes that implement the attack action method. Each attack method will enable different types of attacks: a melee attack, a ranged attack, and use the create method of the factory to instantiate the required enemy object. All right, so there's the enemy spawner. Here's a bullet creator. Create a bullet interface that has a payload method, right? Create concrete classes that implement the payload method. Each payload will enable different effects: explosions, area of effect, damage type, etc. And use the create method of the factory to instantiate the required bullet types. This is a great way of using the factory method. Some kind of enemy spawner or bullet creator is something that we've seen over and over again. They're very successfully used this way. Okay, so questions for you guys before we move into the demo, which is next. So again, they're a little bit different than what we've seen before. Okay, an interface is something that you may have not seen before in C++, right? Or if you've never done Java programming or any other kind of language, and all you've worked with is C++, then interface in your mind is a .h file, or something like that. Or whenever you think about abstract classes, you think about pure virtuals. Yes, but not in C#. In C#, you can actually mark a class as abstract, and we'll talk about those things, okay? Let's get to it. So what I want to do right now is I want to, for the next piece, for the demo piece, we'll go for another half an hour, and then we'll take a short break, and we'll come back and then finish it off. For your Lab 4, what is Lab 4? Let's talk about what I'm asking you to do for Lab 4. So Lab 4 is around the factory method pattern. And again, we're going to use this example. It says to create an object pool to optimize memory utilization, but we're going to use the factory to create to draw from the object pool, not necessarily the way it was done before. So let's talk about how this is. By the way, the factory method pattern Lab 4 is due this week, Friday, October 15th, as normal at midnight. So I'll give you a chance to practice what you've been doing, what we talked about in class. All right, so what I want to do now is let's take a look at our Unity Hub and see what we had from before. So bring up Unity Hub, right? We had our GAME2014 Lab 3B. This is where I'm going to start this week. So I'm going to start with this, Lab 3B. So that'll be our starter. And if you want to look at up online, let's do that. So we'll say github.com/George Brown. And we're going to have Lab 3B. So it's the last thing we did, this one. So I'll just copy this and make this our starter, and we'll modify it from there. So again, in our content, under the content collection, which is up here, then inside of week 6, you're going to see a starter. Let's do that. So this will be our week 6 starter, okay? We can also look at this as Lab 4 starter. I've done that in the past as well, but that's fine. And all this is going to be is a place where you can access the last week's GitHub repository really quickly. And this is where we're going to start. We're going to start from last week. We're not going to redo everything we did last week. We did a lot of little work on our bullet classes and everything else. And we're going to do something that's we're going to extend what we did last week with our new stuff. Okay, so let's get to it. So what I want then is if I have this, I want to show and explore, right? Here's my Lab 3B. And if you worked last week with Lab 3B, I want to take Lab 3B like I did in the past, instead of downloading everything, and make a brand new structure here. Can you use your own repo if you want? I'm just offering up a starter just in case, Vineet, that some people weren't here or weren't able to complete Lab 3. So that's why I'm offering Lab 3B as a starter. But yeah, if you want to, just make a copy of your repo for Lab 4. Right? So again, what I'm going to do is I'm going to make a brand new folder. So we're going to call it Game 2014 Fall 2021, and then Lab 4A. This is you guys. And what I want to do is go into Lab 3B. You can do two things. You can download Lab 3B and rename it if you want to, or what I'm going to do right here, which is I'm going to modify what I already have, right? And start with Lab 4A. Let's see how this looks. So Lab 3B, I don't want a couple things here. I do want the GitHub, I do want VS, I do want everything here that's here. Let's highlight all. So again, highlight all. But I don't want, here's what I don't want. I don't want the library folder, right? And any builds folder. So please, if you have a builds folder here, ignore it, please. Library folder by itself is 400 megabytes. We don't want to copy this. So copy this whole part and then go into the new lab and paste it, right? And you're going to see pretty quick to paste without a library. But we do have this .git folder, and the .git folder needs to be modified a little bit, and we're going to do this right now before we start. So again, I'm going to go into GitKraken, which I find is a pretty good tool. You can use whatever tool you want, though, if it makes sense for you. It doesn't matter to me. You don't have to use GitKraken. You're not going to be, quizzed on how to use GitKraken ever. It's just a tool for us to use. So instead of I want to start a new repo, I want to open it instead because I already have one in my case. In your case, if you've downloaded you can clone a repo. So you can clone something that already exists and you can repoint it somewhere else. It'll be the same thing. Let's do open a repo. Okay, it's up to you how you want to do this. I want to open an existing repository, right? And I want to look in the desktop under GPC in Game 2014, and the new thing I just made, Lab 4A, there it is, and select folder. And this is going to have a bunch of files here that I already have. But on the left, notice that I already have a remote. I need to remove or repoint this remote to the new repo that I'm making online for today. So I'm going to go here, and I'm going to remove my origin remote. No more remote. Hey, if there anything to add, if I have to add any objects, which I don't have anything to add, I can do that here. But what I want to do now is just simply, now that I've copied everything, I have all my commits from last week, plus all my commits from the week before. What I want to do is I want to push this up. So click push. It's going to say, hey, there's no more remote. Do you want one? Yes, I do. It's going to pull up my little dialog box. And what I want to do is I want to select my repo account. That's you. I'm going to make it public. You can make it private if you want, right? And then from here, I'm going to create remote and push local references. And this is what's going to happen now. We still have some issues because my README file needs to be updated, right? So if I look at my README file, right, it needs to be updated. If I right click, by the way, here, and you look at this, I can change the commit message. It's interesting. I can do that. If I have a problem with any of the commit messages, I can do that. And that's really cool that I'm allowed to do that compared to before. Let's go back to Unity Hub, and I want to open a repo. Well, I just made Lab 4A. I'm going to open this one up. That's the one I want, and click Select Folder. And it's going to try and launch Unity. And this is okay. Before I put it up again, I'm going to modify the README file in a second when I put it up. But you're going to see how this brings up everything that we had from last day in here. Okay, so again, I'm just showing you this stuff so that you've seen the process. You've seen the process of how to, if I'm going to bring it up, how do I do this, kind of over and over again? Because sometimes what we want to do is we want to continue from what we had, but yet create a new repository. So I want to keep my old repository, right? So it's like, I can always revert back. I can always go back to that other repository. If I have a problem with the direction I'm going to right here, I can go back to lab 3, and I have a perfect thing that was working from last week in lab 3, right? As opposed to me having, have a chance to break this thing that I'm making if I just, continue with what I did last week, which is what I don't want you guys to do. I want you to make a new repository. Whether you point to a new one or whether you make a new one like I just did, it's up to you. But it has to be new. Please don't use the same repository every single week. All right, and I'll wait till this pulls up here for a second. And so pretty good stuff, in terms of, what we've talked about so far. I want to talk about the Singleton. So remember the Singleton, how it works. For the people that, that have had me in the past, and if you're new or if you're coming back from a hiatus and you haven't used STL Engine for whatever reason, and you're just completing your third year here at George Brown, you may have not seen the Singleton in use that I've made use of in the STL Engine example that I gave you guys in your C++. Okay, so that may have not been the way to do that we've done it. Also note that last week we had some basic movement, and I didn't use touch interfaces at all. We haven't talked about that at all. Next week is we're going to first talk about it for the first time. And when I run this thing, you're going to see that nothing runs, because remember, whenever we download a project from from anywhere, or even copy, and we remove the library folder, then the scene that we're opening up is an untitled scene. We don't want to go there. We want to go into the scenes folder and double click on start. You can see we have the start button where I can start the game, and you can test it by clicking start, and it goes to this little thing here where we have a bunch of enemies that are killing us with bullets. Okay, so that's what we had last week. And what we did was we used we used a bullet pool. Let's take a look at the scripts. So we had a bullet manager, right? So here's our bullet manager from last week. And the bullet manager, all it did was we use a bullet pool. We used a queue for the bullet pool. This is a special type of structure we talked about before. And again, from a data structures and algorithms perspective, if you look back, if you remember queues, what they are, they're just like lineups. So if I line up for a coffee, right, first come, first serve, right? If I get in line and I'm the next person up, that's the next person. And that's how the queue works. So if you looked at the, if I look inside of the, let's go to the proper scene. Let's work just with the main scene for now. So if I look through here, I got a bunch of enemies. Let's just, for this particular example, get rid of all these. I have a bunch of enemies. We'll think about maybe a better way of using enemies, right? So I want to get rid of all these. And I just want to have a single enemy now. So the single enemy kind of, does the same thing, just casts a bunch of bullets down, right? Looks kind of random. And the game controller, when I run it in the game controller, one thing we did last week was, and I'll talk about this in a bit, I modified my code so that it uses dynamically sized, bullets. So for example, right now my bullet number is 15. So instead of presetting my bullet code to say I need 20 bullets, 30 bullets, 50 bullets, whatever, it only uses the minimum amount of bullets for the first time. Let's take a look at that again. Notice my game controller, it says bullet number is 0. This is different than the code you had last week, okay? Take a look, please. Be careful, because we did this with the second section, but not with you guys. So how does this work? If I press play, take a look at the game controller, right? You can see that it starts off with 1 bullet, 2 bullets, 3 bullets. This is the bullet number that I have, and it adds bullets to the pool due to my demand. So now, when I first start playing, I have a small number of bullets, 13, but then it can expand to 16 or so on, okay? Take a look at that, but no more than the ones that are required. It won't continue to create bullets if we have bullets in the pool, but this is another type of bullet manager that actually is dynamic in that it dynamically creates the bullets that it wants, and then once it creates the bullets in the beginning, so there might be a bit of instantiation the first time that this game runs, you can see that we only add an extra bullet when it's required. So we actually save memory this way as well. Another optimization. Take a look. So how does that code look that's different than last week? Let's take a look on what we've done. So if I go to the bullet manager, look at the bullet manager now. The bullet manager says that, okay, I want a bullet pool, which is of type of queue, right? We don't need this anymore. We don't need to build bullet pool anymore. Build bullet pool, right? It actually doesn't work. We don't call build bullet pool anymore. Instead, we call add bullet. And when add bullet is created, right, the bullet pool also calls add bullet. We've extrapolated or extracted the body of the for loop inside of bullet pool, build bullet pool, to something called add bullet. And what it does all the instantiation. It say, hey, var temp bullet is equal to instantiate this. Yes, thank you very much. And then we say temp bullet set active to false and all that stuff, and we on queue it as we need. This is adding a bullet. So that's what bullet pool does. But we don't add a bullet to the pool unless we have no more bullets to add. So example would be, instead of pre-instantiating all the entire pool, in this case, is another variation of the bullet pool. Instead of pre-instantiating, what we're doing instead is, when the bullet class is called, or getBullet is called, right? As an example, when getBullet is called, if the bullet count in the bullet pool is less than 1, then we add a bullet. We do this whole instantiation business. And we increase the bullet number that we show in the inspector, okay? And then what we do is we dequeue that bullet, we send it out into the real world, we say, fly, bullet, fly, and it goes into the real world and does its damage, and then eventually it does what a bullet does and comes back into the bullet pool, right? But if this test fails, so for example, if there's already enough bullets in the bullet pool, it will not create new ones or increase the number of bullets in there. Instead, what it's going to do is just going to use the bullets that are already there, okay? So, sorry, Sam says, copied lab 3, use case stepped out, blah, blah. And we're just using dynamic object pooling here instead of kind of fixed object pooling is what we did together. And this is just a variation. So, okay, advantages of this code compared to last week's code. We kind of talked about that as a review. An advantage is Well, I only use the amount of bullets that I need. I only instantiate the amount of bullets that I need in my game controller. All right, so let me take a look at that. So again, if I only have one enemy, then guess what? My game controller only has the amount of bullets that's required when I'm shooting bullets out. If I have enough bullets in my pool, I don't make new ones. Okay? But what about, let's run that again. Watch this. What about if I run out of bullets? Now I can never run out of bullets anymore. Why? Because what if I have in my prefabs, I decide to add in another enemy. So let's just drag and drop another enemy in there. Hey, there's an enemy clone. Now, if I go back to my game controller, I'm going to add more bullets because the double the demand, right? So no, so far I have 20. Now I'm going to 24 before I started off with less. And what happens if I delete an enemy? So I go back and say, goodbye, enemy. I don't want you anymore. It doesn't matter because my game controller retained the memory of how many bullets I required in the first place, 28, right? And now I've already instantiated and I keep that memory amount. There's a further optimization you can go here. For example, if I only feel that I need 14, I can start removing bullets. I can start, removing memory and, kind of going that way as well. So it's a little better than instantiating and destroying directly. Disadvantage is in the beginning when we first start off, as an example, the disadvantage is we have to instantiate a bunch in the beginning, right, in real time. We don't do it ahead of time. But then later on, things stabilize and we don't need to instantiate anymore. We just reuse the stuff that we already have, okay? And we're never destroying, ever. We never, ever destroy a bullet, okay? That's the, kind of the disadvantage and advantage built in, okay? Memory optimization wise, this is less optimal in terms of fragmentation because we're still instantiating stuff, right? We continue to hit in the beginning for how many bullets we need, but more optimal in that it's dynamic because we can't really know how many bullets an enemy would need, and it's safer because if I was to put a number of bullets that I think they need, let's say in this scenario, we think it needs 20, but it actually needs 30, right? As an example, I wouldn't know that unless I'm doing some, kind of trial and error. And a procedurally generated game, this could be catastrophic. It could break my code. But here, if I'm dynamic, then I create the bullets that I need. And I can continue to add more enemies to the scene, right? Let's say I instantiate more memory or more enemies come into the scene. And as they come into the scene, they create more of a demand for bullets for this particular scene. Well, then I only add the bullets that I need, but I don't go higher than the number that I'm required. So for example, all these enemies only use 78 bullets, which is a very specific number compared to what I could think about what they would need myself. If I was kind of estimating how many I think they need, I might be wrong, right? That's kind of going back to what Sam says. Last week, Sam said it when he said, well, what if you don't know how many bullets you need? Here's a way of dealing with that, okay? All right, so that is what we did last week. So now what I want to do is I want to think about making a factory. So what now is if I want to make bullets, but I want to make bullets that also the player can use. So whenever the player presses the space bar or whatever, I want them to use the same structure that I've done before. I don't want to reinvent the wheel here, right? I already have the wheel. Look, I have my bullet behavior, right? Now let's start low. And what I mean by low is think about the bullet behavior. The bullet behavior has a couple things, right? My bullet behavior always moves down, right? It always moves down. And really what I should say is the bullet should work in any direction, really. Doesn't matter which boundary I'm leaving. The bullet should be more resilient in terms of where it's leaving. Instead of destroying, we're never going to destroy any game objects ever. We're going to get rid of this. Instead of destruction, we're not going to do destruction. We're going to do returning. We're going to return it back to the pool. But we want to do it not just when the transform position Y goes beyond max. We don't care about that. But what about if the transform position Y goes beyond min, like at the top or on the sides? Or whatever, right? So first, let's modify our bullet. And we have to know a couple of things about our bullet, right? One of them is the bullet firing direction, Okay, is my bullet firing direction up? Is it down? Is it to the right? Is it to the left? There's different scenarios here where I can have my firing direction can be in different places. We don't care about, there's a couple things we don't care about. We don't care about the type of bullet. For example, the one thing that we're going to be doing here is saying, hey, I want this bullet to be attached to, or the bullet behavior to be attached to all bullet types. Doesn't matter what bullet, okay? Doesn't matter what bullet. I want the bullet behavior to be attached to all bullets because they're all really relatively the same. Okay, so that's one thing we have to know. So let's start with the bullet before we make any factory. So one thing is the speed is okay. I like the speed. This is okay. Move, well, this has to be modified because it says the transform position is only going to go down always. So direction is kind of a thing that we want, right? Some kind of direction, whether it's up or down, left or right. What's the direction of the bullet being fired? We should know that. Let's make an enumeration for this, so to help us out. So again, we kind of did this last time where I had some things like this, right? I have a bounds structure. I made a struct last time. I have a bullet behavior and a bullet manager, enemy behavior, the game controller, and a bunch of other stuff. And I have something called UI behavior, which is the button presses that we did last time. Let's make another type of class. So I'm going to make a new C# script. And we're going to call this the bullet direction. Very specific. Bullet direction. And my bullet direction, if I double click, right? Let's bring up my bullet direction here. My bullet direction, instead of inheriting from mono behavior, we won't do this. Let's get rid of this piece. So it's not inheriting from mono behavior. In fact, instead of my bullet direction being a class, let's make it an enum, which also exists here in C#. Our bullet direction enum should be system serialized, so we can see it and use it anywhere. Again, it's going to be system.serializable. All right, so that's one thing we should do. And then in my bullet direction enum, let's put in some directions for it. For example, let's start off in a clockwise order from top, right, bottom, left, right? So we're going to say up, right, down, left, okay? So we're up is 0 and right is 1 and so on. Okay, this is just an enumeration with some friendly text to show us which way it's going to go. Okay, so bullet direction. All right. Remember, we want to reuse our bullets, right, in more than one way. So how do I use bullet direction? Well, if I go back to let it work its magic. Let's go back now to bullet behavior, and we can add an additional property up here, which is public. This is bullet movement, right? We can add another one, which is bullet type, right? So actually, we should be able to include this in bullet movement as well because we have the direction of movement. So actually, we can reuse the header, right? So we can say something like speed, bullet bounds. Well, what about, the direction? So again, we'll say public, and then bullet direction, and in the bullet direction, we'll just call it direction, okay? So how does this appear? Does bullet direction, which is our custom enumeration, does that appear at all in the inspector? And let's take a look and see what this is. So let's take a look here, and we can see on the right, if I look at my prefabs and I click on a bullet, which in this case is called enemy bullet, right? And if I scroll down, let's just hide some of these things. We don't care about these things. I do care about bullet behavior. And let's put our box collider up a little higher, right? So far, our box collider is kind of low. It should probably be before my bullet behavior script. So let's put this up a little higher. We can move this up. Okay, good. And notice that bullet behavior itself has now a bullet movement and bullet bounds, but there isn't anything in the bullet. Now it says one thing. It says the type namespace name bullet direction cannot be found. Are you missing a reference? So what's the problem there? Why is it Why does it have a problem with bullet reference? It says there's a problem with the compilation. So bullet behavior, right? I'm trying to add in the script that says, the bullet direction, and it can't find the bullet direction. So why can't it find bullet direction here, even though it's a public enum? Notice that I mean it finds it here. Here's the enum direction, right? But it doesn't find it down here. Now this kit, if you may have not, kind of come across this problem, it says assets, bullet behavior, the type of namespace, bullet direction cannot be found, or missing a using directive or an assembly reference. Do I really need that? I'm just putting it out there, guys. What did you guys find? Did you guys find an error like this or not? What did you guys get? So again, all I'm using with bullet direction is, let's go back to the code for a second. All I'm doing with bullet direction alone is I'm just using it as a, the thing that I want. Notice it says here that my namespace does not correspond to the file location, should be in assets. Huh? What does this mean? Well, this is the thing that happened. So when I created my script, somehow Unity wasn't happy about what I did. So let's just we'll redo this whole thing for a second. Bear with me. Let's go back into bullet behavior 1 sec. All right, and let's just comment this out, just for now. And let's just delete. Let me just delete my bullet behavior, my bullet direction one more time and put it back in. Because remember, one thing we can always do with any of this stuff is show and explore. Let's see where this thing got put. Here's bullet direction here for the first time, right? Bullet direction got here, and it was put inside my assets, but somehow, for whatever reason, my project didn't see this as a proper location for this thing, right? So just so that way we don't have to redo it, I'm just going to grab all of this code, and I'm just going to delete it, and I'm going to slap it back in, okay? So sometimes Unity does funny things when I do copy and pasting of project information. Some people have asked me that in the past. They're like, I didn't have a problem until I did it your way, and then suddenly I had a problem. Well, yeah, there's a problem. There's a reason why. So let's, from a bullet direction, let's delete this. And what I want to do is back inside of Unity, let's do a couple things here. One thing is, it's going to rejig this in a second, and it might even crash Unity. Did it crash? No. I want to file save, and I want to file save project, and then let's get the heck out of Dodge and close this down for a second. One thing to note is whenever we open up a project, right, as an example, in Lab 4A, you're going to see a couple of different solutions. Solution A, B, C. Let's get rid of these other ones. Delete. So we don't care about this one. We care about this one, Lab 4A. This is an important thing. When we put it back inside of our assets, that's where the file should be. Sometimes the structure with logs and objects and all that stuff messes up. And again, one thing, the way to fix this, you may not have got it if you download it from the internet, is sometimes we need to remove logs and the OBJ package, as well as some other things like project settings and so on, in order for us to do that. But I'm not going to do that right now. I'm just going to keep it, and hopefully it'll correct itself when I launch Unity one more time. Let's try that. Sometimes it corrects this way. Sometimes it won't. Let's see. All right, let's try that again. So again, I want to create a new C# script, and we're going to call this bullet direction. And so far, no error. I saw the error come up last time, and I ignored it, and I'm not going to ignore it this time. So far, no error for bullet direction. Let's go back and just replace everything here with the code that I have, and let's see if this makes any sense. One thing is we don't need Unity Engine because we're not using Unity Engine to attach this to anything else. We can save that code and go back, and hopefully that's not going to cause a problem like before. So bullet direction seems to be okay so far. What about the bullet behavior? Can I uncomment this code and save it? And what does it do now? Does it still have that error, that red error that came up that says, I don't know where it is? I know this is dumb, but it's key, right? So it didn't come up with the error now. All I did was rebooted Unity, and I kind of made it again, made the same bullet behavior thing. Sometimes you have to do that. If I go back into prefabs and I go back into my enemy bullet now, well, look what I have. I have a new pull down that goes up, right, down, and left. Right? So enemy bullet, guess what it should do? Down. Right? And why? Because that's going to show us where it's going. And now our bullet bounds is all we care about is down. I want to make a copy of my enemy bullet, right? And I want to change some stuff. I want to change the renderer and whatever. But really, I don't need to do it so much, right? My enemy bullet and my player bullet are almost identical. The only difference is that the sprite renderer, instead of it looking at an enemy small bullet, it's going to look at something else. My box collider is going to be a little bit bigger because my player bullet's going to be different. But let's just do a copy paste. So again, I'm going to do a Control D, which is going to copy my prefab from enemy bullet, and we're going to call it player bullet. So here's player bullet. And right now, player bullet looks identical to enemy bullet. Looks like this, right? And instead of my player bullet being that, we're going to change the sprite renderer so it points somewhere else. But we're also going to change the direction from down to up. Right now, our code doesn't support it, but that's okay. That's the first thing I'm going to do. So the direction is up. We can also support right and left, but we're not doing anything like that right now. Okay, so right now, our player bullet direction is up. So that's where it's going to trigger. It's going to go up. And our player bullet has some other issues, right? Because it doesn't look like a player bullet. It looks like the enemy bullet again. Let's see if we can find a player bullet that is here as well. Notice it says enemy small bullet, and then it has a power up, and there's also something called bullet. And the bullet looks like this. It looks kind of like a red bullet. If I double click on this, it's going to add this bullet now instead of the other one. Let's put the bullet so it's closer to the player. So I want to go into the game scene here. All I've done again is I've gone into sprite render and just retargeted the sprite so it looks like at a different direction. One thing we should also check with this thing is what does the the bounds look like? The bounds look like they're pretty good, right? So if you want to, you can change the bullet, because remember this box collider was added to support the enemy bullet, so it's slightly longer. And notice it kept everything. It kept everything because we never changed anything. It's just going to automatically figure things out. So let's modify it so we can make it so that it's tighter. So I'm going to say it's like this. You can actually zoom in here so to be really specific. So that's we want to make it a box collider because it's just a bullet. We don't want to give a lot of overhead to the bullet itself. Again, you can also remove and add a new box collider and it would just do the same thing. I'm just doing it manually here. All right, so that's the box collider 2D. Yay, that's awesome. We've added a bullet behavior. And what I want to do with this bullet is I want to go to overrides and I want to go to apply all, which is going to apply everything for this particular bullet. For our player bullet, it's always going to be in the up direction. And for the player bullet, it's always going to have the bullet sprite as opposed to the enemy small bullet. So if I brought the enemy small bullet in there, here's enemy bullet. And you can see the difference. So let's let's use the player bullet to pull it down. You can see the difference between the two bullets, right? One, the enemy bullet's slightly larger than the player, right? And the player's different color, and the player's bullet has a different direction. Okay, cool. All good. Well, just like the enemy bullet, the enemy itself, the player needs a bullet spawn location, right? So just like we did here with the enemy, we had a bullet spawn, right? I want to Control D, make another bullet spawn, and just pass it into the player. Except what we want to do with this transform is we want to reset it. So right now, if I looked at the bullet spawn location for the player, right, it's like way up here, right? And that doesn't make any sense. So I just want to reset this thing. So reset puts the bullet spawn location on top of the player. And what I want to do is I want to move the bullet spawn location in front of the player at some distance. So this is where the bullet's going to come out of. Again, I'm doing it by eye, but you guys can be more scientific about it. You can size the bullet, see how big it is, all that stuff. So the bullet spawn is required because for the player object, remember that the bullet itself will need to know where it's going to be created, because I'm going to call, the bullet manager is going to call from the factory, and I'm going to call a bullet into being. Okay. So that's bullet spawn. I need bullet spawn. And because I added a new object that is a sub-object of the player object itself, what I want to do is for the player, I want to override. So on my player prefab now also has a bullet spawn location. Okay, so that's kind of required. So I got my enemy and I got my player. And I've got a player bullet and I got an enemy bullet. Now, one thing we need to do is go back to that code. So again, going back to scripts and going back to bullet behavior, right? We should really look at what's happening here. So bullet direction, and this, after we do this, we'll see how this works, right? So bullet direction does a couple things for us, right? One thing is it talks to our speed, our bullet direction, right? So depending on our movement, if I'm going to be going up, then I'm going to be adding. If I'm going down, I'm going to be subtracting, right? So again, it really depends on what I want to do, right? And so this is something that I have to change. And also this is something that I'm going to have to change, right? So check bounds, well, I'm going to check both bounds, right? Whether the top or the bottom. That's just an extra check. So this one checks bottom bounds, and I can also check top bounds. So check top bounds, and we can have almost the exact same code here, except it's checking in the min location. If it's greater than min, right, which is way up there, then I want to return the bullet. So if I go off screen to the top, then it's also going to be returned. If it goes off screen to the bottom, it's going to be returned, right? So I need to modify my bullet code a little bit, right? Now this one is the one that you can argue about how you would do this. Remember, I have speed, right? And my speed is up here. So a couple things to do, right, is if I could have two statements here. If this, then that. If this, then that. I can have a switch case as well, right? I could do that as well, a switch case. For now, let's just do something that looks like this, because there's only two states, depending on if it's up or down, right? Those are the cases. If I don't, then I can always do a switch case for the change the speed. So my speed, remember, is a new vector. And right now my vector is hard-coded so that it can't go on the y-axis. It can't go right and left, right? That's how I've made it. So I could define a speed vector. So instead of a speed being a float, I could call it a velocity vector or something like that, because now it'll have magnitude and direction, okay? So let's do that instead. Let's make a new velocity vector, which will be different than the velocity vector of a rigid body. It'll be my own, okay? So again, we might want to make this private. We'll call it a vector2, and we'll call it velocity. It'll be our velocity, whatever we want to define, okay? And our velocity is going to be this piece, okay? Whatever the velocity is going to be, right? And in the start, when the bullet's instantiated, this is the perfect time to add in the velocity. We can say that, right? Depending on the case, that the velocity will be different. So let's think about this. We have some help for this to be done, right? We have some help. And we're going to do it dumb in the first place, and then we'll do it smarter afterwards, okay? So one thing is, when we look at the bullet speed itself, when it comes to bullet speed, if we look at bullet behavior, right? And if I look at the bullet itself, the prefab, we should keep that in mind as well. Notice the speed factor is low, 0.1, okay? That's a thing to note. So we know it's going to be something like 0.1, whatever the speed is going to be, and that's what's going to be the thing that I'm going to plug into my velocity, right? Okay. That's one way of doing it for sure, right? So we can do a switch case. And The flags are going to be the bullet direction. So I can say the direction is what I want to switch. When I'm creating my bullet, right, then I want to say that, and then you can do this case. If I want to say bullet up, right, then I can do something, right? That's one case. And I can also do different cases. Case bullet right, because we're going to go in a clockwise direction. We're going to follow this same thing. We could do it this way. We could, all right? I'm hoping you guys are thinking about other ways of doing it now. And here's bullet left. So those are the four cases you can possibly have for the bullet. Right now, we're only caring about up and down because we only have an enemy bullet, okay, and a player bullet. So if I go up, then I can take my speed factor, right, and my speed factor will be a new vector. So I can say something like my velocity vector will be in the upwards direction, right? So I could say something like that's equal to a new vector 2D object that has my speed in the positive direction, okay, as an example. So I could say something like on the x-axis, right and left, it's 0.0. I'm not moving up, I'm not moving right and left, but my speed is in the upwards direction, so I'm going to put speed in there. That could be something that I want to add. So velocity is equal to this, right? If I'm smart, I might make it so it's vector 3, right? Because then I can do something that looks like this, plus equals. I can use that shortcut, right? And then we don't really care about the y, about the z-axis. The z-axis is always going to be 0, right? So that's something that we can do. And then this same code, if you think about it, a little bit of code duplication. By the way, there's also a vector 3 up, a vector 3 left and right, and we could think of other ways of doing that instead. But here, we're just going to make our own little vector where we have to the right then would be more like this, speed to the right, and down would be a negative speed, and to the left okay, so we're just configuring the bullet direction, right? So once I have my bullet direction, depending on the bullet direction, I'm going to have a new velocity vector, right? And then what I can say is, well, my transform position is, instead of minus equal, let's use the plus to make it positive. And we'll say plus equal to my velocity vector. Oh, velocity, okay? Whatever the velocity is that we can say. And if you don't like velocity because velocity hides the velocity, which is what this is saying, we can always refactor, rename. So refactor, rename, let's call this bullet velocity, right? Which is more descriptive. So we can say that transform deposition plus equals to bullet velocity, and that'll give us the direction that we're going in, as well as the speed based on the speed that we're getting up here. Okay, whatever that speed is. By the way, there's no diagonal. And if I wanted to, I could add to the enum to add in whatever the case I want. Okay, just to give you some simple way of doing it, we're just doing it this way right now. All right, so let's see if my enemy bullets work properly. If my enemy bullets are configured so that they're going in the down direction, does it still work? Before we do any kind of bullet firing with my player. All right, so run. We should just see the same amount of bullets go down the stream if we did it right. Yay, they're still going down, which is what I wanted. And they leave the screen down here. Okay, what if I also add a player bullet? What happens? Well, it goes up the screen, and you can see it goes up, and it keeps going up, and uh-oh. Wait, what? That added back into the pool somehow, and sometimes the enemy fires my player bullet now. What if I add some more? Right? And let's add some more player bullets. What happens if I do that and I want to add as many of these player bullets as I want? What's going to happen? Well, I'm going to get some bullets that fire in the up direction from the enemy. That's a problem, right? And why? Because it's going to the same pool. Take a look. So you can see that inside of my game controller, right? I have some enemy bullets, and I also have some of my player bullets. They're also being kind of put back into the pool. You can't see it here, but actually the player bullets are also in my pool now. Why? Because of my code, right? And let's take a look at that code, where that is. I'm putting this out there because there's still work to be done here. We're just not even doing a factory yet. Right now, we're just prepping, all right? So remember we said factory, when we don't have a factory, it takes a little bit of time to put a factory into place. So now we have this check bounds. This is okay, but then what we say is, let's return to the bullet manager this bullet. Right? Right? That's what we want. And so the bullet itself gets called and it doesn't care, right? Whatever kind of bullet we have, it's going to be returned to the bullet manager. So that's a problem. So we can have multiple bullets, right, in here. And we can kind of figure out that the only type of bullet we want is the enemy bullet, not the player bullet. They're still in the same pool, but we don't care about that pool being, kind of calling the other ones. We want this one, okay? So this is an issue because we're always returning it back to the bullet manager, regardless whether it's on the top bounds or on the bottom bounds. So this is something we're gonna have to deal with. We're not gonna deal with it right yet. Okay. And I want you guys to think about some possible solutions here, okay? Because we want to try and reuse this script as much as possible. In the first time when we got together, when we first started doing this course, right, I was okay with duplication. But now what we want to try and do is reduce and optimize, right? So now that's the stage that we're at. Okay, cool. So that's our bullet manager then. What does it do? It says, well, I can get in the return bullet method. We don't care which bullet gets returned. It's a game object, right? That's why this works, right? And it sets the bullet to false and puts it into the pool. That's what it does, right? So regardless of what happens, the bullet gets put back into the pool, and we don't care what kind of bullet it is. But that's a problem when we call the bullet out. When we call the bullet out of the pool, all I want is a specific type of bullet. So whenever I do call add bullet then, right, add bullet, when I add new bullets to the pool, that's okay. But when I remove bullets from the pool, and add bullet, by the way, it only adds enemy bullets, right? Because it looks at the bullet prefab, a very specific bullet prefab for this kind of stuff. And this is where everything is tightly coupled. Our object pool and our bullet that we have are totally different. Well, you're right, Sam, but bear with me here. Because if you think about it, once we go to the factory, do we really want is the bullet pool manager, is it going to have the bullet pool? Is the factory going to create our bullet for us? How are we going to use this thing? Okay, so yes, we could do that. We can have separate pools for this. Separate pool for enemies and a separate pool for stuff. We can have separate pools for everything if we really want to. So our bullet manager could have two pools, right? We could have two bullet prefabs or multiple bullet prefabs, one for the enemy and one for the player, or multiple bullets for the player, multiple bullets for the enemy to give some variation if you really want to. All right, so let's take a short break, and I want you guys to think about now, how would I implement this bullet pool factory? How do I do such a thing, right? One way to do it would be to create another object, right? Or we can attach the bullet pool factory for now. Let's attach it to the game controller for now, right? And then we can think about, how do I remove this or make it simpler? How do I make the bullet pool factory more usable? So where I would start before I come back, let's see if you guys can start it up before I start it. And I want you guys to think about the stuff inside the PowerPoints. Go back up here, and inside the original bullet pool, think about this structure, right? Where we have some kind of function that's called create something, right? And so this create something function is going to come from the bullet pool factory itself. For now, let's not make it abstract to keep it simple. Let's just do one of these. All right. So create enemy bullet, right? Or create whatever. And then we'll see if we can make it so that it's more usable. It can do any kind of bullet we want. So let's see if you guys can do it. I'm going to come back. Right now we're sitting at 1:55. 5 minutes. We'll take a short break, do a bio break, come back, and start back at 2. All right? I'm going to stop the YouTube video. Okay, and I'm just going to